Hey, Matt Mathersum here with Math Madness. Thank you so much for joining us and being a part of the program today. We appreciate it. Well, for today's discussion, I thought, let's see how we can use triangles and proportions to calculate the height of an object. And let's just go ahead and head straight to the board so we can see what we're working with. Let me step over here first. Okay, I got a few things that we're going to throw into the mix here. First, we are going to be calculating the height of this tree here. And to help us with that is going to be my cousin Lance and his very charming daughter, Cora May. So let's go ahead and bring these guys up on the screen real quick if we can. And there's Lance with his daughter Cora May again. All right, so this is how this is going to play out. We're trying to solve for the height of the tree here. We're going to be using triangles and proportions to calculate the height of this. And so let's just go ahead and draw in our triangles real quick here. From the tree here to the shadow, that's what this is here. I know my artwork is definitely not on the Picasso level, but I'm working on it. So here's our triangle from the tree down here to the shadow, and then up the tree. And the height that we're solving for is represented by X. Now over here is going to be Lance. And I've got him at about 6 feet. I'm 6'3" roughly. I know he's not taller than me, and I know he's not less than 6 feet. And to represent that, I thought, well, let's do some inequality notations. This is kind of last minute that I threw this in here, but I thought it's a great time to implement this. So I know that Lance isn't any smaller or shorter than 6 feet. Let me make our notation here, the 6 feet. So I know he's at least equal, which is what this is, or he's greater than, which is what that is. And together, this is an inequality. If you haven't been exposed to this, that's exactly what this is. So I know that Lance is equal or greater than 6 feet, but I also know, because I'm about 6'3", I know he's not taller than me. So I know that he's at least 6'3" or less. And that's what this inequality represents here. And here's Lance in the middle, and you've got the values from 6 feet all the way up to 6'3", which would be my height. Okay, I just wanted to throw that in because I thought this is a great time to demonstrate how that would work. Okay, let's solve for X over here, again using Lance and Cora May to help us find the height of this tree. This tree is, at this particular time of the day, giving us a 20-foot shadow here, and Lance is getting a 8-foot shadow here. Again, whatever time of the day this is. That's why this is proportional. Okay, speaking of proportions, let's go ahead and solve for X. And let's just put our X on the top because this is proportion. And speaking of proportions, we have to keep that in line with Lance's height, which is 6 feet. So I've got X over 6. I'm doing apples to apples, right? Now let's do the oranges to oranges. And that's going to be our shadow of the tree. And that's going to be Lance's shadow at 8 feet, right? Well, what kind of symbol should I be putting in here in the middle if I'm doing proportions? Well, proportions means equivalent, equal to. So that's what I'm going to put here. And I put the tree value on top, which is X. That's what we're solving for. So I'm going to put the 20-foot shadow of the tree on top as well. Well, what's going to go on the bottom? What's going to be Lance's 8-foot shadow, isn't it? All right. Well, a little cross multiplication, a little division, and what? Yep, we'll be home free. So let's go ahead and take 8x. I'm just cross multiplying. That gives us 8x. And again, proportional to 6 times 20. I'm sorry. Yes, 6 times 20. Okay, yep, that's what I meant. Okay, well, we're trying to solve for x, right? We want to isolate x, but x is being multiplied by what? 8. Right, so how do we get rid of the 8 so that we can solve for x and isolate? Yep, inverse operations to the rescue. If it's being multiplied, what are we going to do? We're not going to add or subtract. No, sirree, Bob. We are going to divide, and that will isolate the x like it did. Well, if I did it on the LHS, you know what I have to do on the RHS? Right-hand side. Yep, I got to divide it by that same 8er, and I will, and I did. So x is now equal to, if I take 120, divide that by 8, gives us 15. So x is equal to 15, meaning that the height of this tree is 15. Well, I'm going to give a big shout out to Lance and Cora May. Thank you for your assistance. And that's all the time we have for here on Math Madness. I am Matt Mathersum. I will see you soon.